Welcome to this comprehensive guide on C# parameters, ref, out, and in. Understanding these keywords is crucial for writing efficient, robust, and maintainable C# code, especially as you delve into more complex programming scenarios. These parameters offer distinct ways to manage data flow within your applications, impacting both performance and clarity. Before diving into the specifics of ref, out, and in, let's clarify the fundamental concept of how parameters are passed in C#. Specifically, the difference between passing by value versus passing by reference. This foundational understanding is key to grasping the utility of these keywords. When you pass a parameter by value, a distinct copy of the variable's data is created and sent to the method. This means that any modifications made to this copy inside the method are isolated and do not affect the original variable outside of it. The original variable's state remains unchanged, ensuring data integrity from the caller's perspective. Conversely, passing by reference means the method receives a direct link or reference to the original variable in memory. This direct connection allows the method to directly access and modify the original variable's value. Any changes made within the method will be reflected in the original variable, making it a powerful tool for shared data manipulation. This distinction between pass by value and pass by reference is absolutely vital for managing data flow effectively and preventing unintended side effects in your programs. A clear understanding helps you write predictable and reliable code. Now, let's explore how the ref, out, and in keywords specifically facilitate passing by reference, each with its unique characteristics and use cases. First, we'll examine the ref keyword. Ref parameters allow a method to modify the value of a variable passed from the calling code. A critical requirement for ref is that the variable must be explicitly initialized with a value before it can be passed to the method. This ensures that the method always operates on a valid, existing piece of data. Here's a simple example in Visual Studio to illustrate this. Notice how the integer variable number is explicitly initialized to 5 before it is passed to the modifyRef method. This initialization is a mandatory step when using ref parameters, ensuring the method receives a valid starting value to work with. The ref keyword must be explicitly used in two places, both in the method's declaration, defining the parameter type, and crucially, when calling the method. This dual declaration explicitly indicates to both the compiler and other developers that the variable is being passed by reference, allowing for direct modification of the original data. In this example, after the modifyRef method executes, the original number variable in the main method is updated directly. Its value changes from the initial 5 to 10, clearly demonstrating the direct modification capability of ref parameters. This immediate change in the caller's scope is a hallmark of pass by reference with ref. Now, let's see ref in action within Unity, where it can be incredibly useful for game development. We'll create a simple script to manage a player's score, where a ref parameter will be used to update the score directly and efficiently, reflecting changes immediately in the game state. Here, the updateScore method takes a ref and current score. This design ensures that any changes made to current score inside the method directly modify the player's actual score variable, which is declared in the calling context. This avoids the need to return the score and reassign it, streamlining the update process. Running this script in Unity, you'll observe the player score in the inspector updating directly and in real time as the game progresses. This visual confirmation clearly demonstrates the ref parameter's immediate and persistent effect on the original variable, making it ideal for dynamic game state management. Next, we explore the out keyword. Out parameters are similar to ref in that they also pass by reference, allowing a method to modify the original variable. However, out parameters are specifically designed for methods that need to return multiple values, providing a clean and efficient way to achieve this. The key difference with out is that the variable passed as an out parameter does not need to be initialized before being passed to the method. Instead, the method must assign a value to the out parameter before it returns. This guarantees that the variable will have a defined value after the method call, making it suitable for outputting new data. Consider this Visual Studio example where a calculate stats method computes both a sum and an average from an array of numbers. It returns these two distinct values efficiently via out parameters, showcasing how a single method can produce multiple results without complex return types. Notice how sum and average are declared in main, but are not initialized before being passed to calculate stats. The calculate stats method is solely responsible for assigning their initial values, ensuring they are properly set before the method completes its execution. This is a core contract of out parameters. This pattern is particularly useful when a method needs to produce multiple distinct results, avoiding the need for complex custom return types like structs or tuples, or the use of less desirable global variables. It simplifies the API and makes the method's intent clearer, especially for operations that naturally yield more than one piece of information. In Unity, out parameters are excellent for methods that attempt an operation and need to report both success or failure along with a specific result. A common use case is parsing user input, where you might need to know if the parsing was successful and, if so, what the parsed value is. Our try_parse_input method attempts to convert a string to an integer. If the conversion is successful, it returns true and simultaneously assigns the parsed value to the out parameter result. If parsing fails, it returns false, and result will be assigned a default value, typically 0 for integers. This elegant design allows us to check if the parsing was successful using the Boolean return value, and then immediately use the parsed value if it was, all within a single, concise method call. This pattern is widely used in the .NET framework itself, for example, with int.tryparse. Finally, let's delve into the int keyword. Introduced in C# 7.2, int parameters also pass by reference, similar to ref and out. However, their unique characteristic is that they enforce that the method cannot modify the value of the passed variable, making them read-only references. Think of int parameters as read-only references. They are primarily used for performance optimization, especially when passing large struct types. By passing a reference instead of a copy, int parameters avoid the overhead of copying the entire structure, which can be significant for large data types, while still guaranteeing data integrity. Here's a Visual Studio example demonstrating it. We define a large point3D struct, which could contain many fields, and then pass an instance of it to a process_point method using the int keyword. This ensures that process_point can access the data efficiently without making a costly copy. If you attempt to modify any field of the point parameter inside the process_point method, the compiler will immediately issue an error. This strict enforcement reinforces its read-only nature, preventing accidental data corruption and ensuring that the original point3D struct remains unchanged. This read-only guarantee ensures data integrity while still benefiting from the performance advantages of passing by reference. This combination is especially useful for performance-critical code where you need to process large data structures frequently without incurring unnecessary copying costs or risking unintended modifications. In Unity, int parameters can be highly beneficial when dealing with large custom structs, such as complex vector types, game state data, or configuration objects. They allow you to pass these substantial data structures to methods without incurring the performance cost of copying them, which can be crucial in a game loop. Our process_GameState method takes an in-GameState struct. This design allows the method to efficiently read and analyze the current game state without accidentally altering it. This is vital for maintaining predictable game logic and preventing subtle bugs that could arise from unintended modifications. This approach maintains optimal performance for frequent calls, such as those within an update loop, while simultaneously guaranteeing that the original game state remains completely unchanged. This predictability is crucial for robust game logic and debugging, ensuring that your game behaves exactly as intended. To summarize the distinctions, ref allows for both read and write access to an already initialized variable, enabling direct modification. Out requires the method to initialize the variable before returning, making it ideal for returning multiple values. And it provides efficient, read-only reference access, primarily for performance with large value types. Choosing the right parameter keyword among ref, out, and it depends entirely on your specific needs for data flow, the intended purpose of your method, and critical performance considerations. Each keyword serves a distinct purpose in managing how data is shared and modified between methods. Mastering ref, out, and it will significantly enhance your C# programming skills, enabling you to write more efficient, expressive, and robust code. Understanding when and how to use each of these powerful features will make you a more effective and confident C# developer. Thank you for watching this tutorial. We sincerely hope this guide has provided a clear and practical understanding of these powerful C# features, equipping you with the knowledge to apply them effectively in your own projects. Don't forget to like, share, and subscribe for more C# programming insights.